Today I'm gonna talk about the derivative of composite function chain rule, general power rule. Now let's take a look at the following formulas. The first one is the general power rule. The derivative of fx to the power n equals n times fx to the power n minus 1 times the derivative of fx. And the second one is the standard power rule. The derivative of fx to the power n equals n times x to the power n minus 1. Here we have a very special case. The derivative of x equals 1. And the third one is the constant rule. The derivative of a constant equals 0. And the fourth one is the constant multiple rule. The derivative of k times fx equals k times the derivative of fx. The last two formulas are for the exponent. Nth root of a equals a to the power 1 over n. A to the power negative n equals 1 over a to the power n. Okay. Now let's take a look. The first example. For the first example, we can tell here we have square root. That means that is not format of fx to the power n. So we're gonna transform it. How to transform it? We're gonna apply the rule of nth root of a, that equals a to the power 1 of n. Okay, so for this guy, we can write it down as x squared plus 1 to the power 1/2. Okay, now we can apply the general power rule, because here the fx is x squared plus 1. Now we have n is 1/2, okay, and fx is x squared plus 1 to the power n minus 1, 1/2 minus 1 times the derivative of fx. So we have derivative of x squared plus 1. Now we can simplify it. And for this guy, it's the derivative of the sum of the two functions. That means we can do the derivative for each function. So we have derivative of x squared, derivative of 1. Okay, and for the first function, we can apply the standard power rule. That is 2 x to the power 2 minus 1. And for the second term should be 0. We apply the constant rule. Now we have 1/2 x squared plus 1 to the power negative 1/2, and this guy will be 2x. We can cancel out 2. We're gonna get x times x squared plus 1 to the power negative 1/2. Since here we have negative, we can continue to simplify it using the last formula. So we can get x divided by x squared plus 1 to the power 1/2. And again, here is the power 1/2. Now we can use this formula. Now we can get x over square root x squared plus 1. Okay, now let's take a look. The second example. For the second example, it's very straightforward. We can easily find the fx. Find fx equals x cubed minus 1. Okay, so we can follow the general power rule. We have n equals 100. Put 100 here, and fx to the power, that means x cubed minus 1 to the power n minus 1 should be 100 minus 1, and times the derivative of fx. So we have derivative of fx should be derivative of x cubed minus 1. So we have 100 times x cubed minus 1, 99, and here is the derivative of the difference of two functions. That means we can do the derivative for each function. And for the first function, we can apply the power rule. We're going to get 3 times x to the power 3 minus 1. And for the second term, we can apply the constant rule, is 0. Now we can simplify it. We're going to get 100 times x cubed minus 1 to the power 99 times 3x squared. We can continue to simplify it. 300 x squared times x cubed minus 1 to the power 99. Now let's take a look at the last example. For the last example, we can transform it. Okay, transform it to the fx to the power n. Then we can apply this general power rule. Now let's take a look. Here things we have cube root, so we can apply this formula. Now let's take a look. 1 over x squared plus x plus 1 to the power 1/3. Okay, and here we can apply the last formula again. We're gonna get x squared plus x plus 1 to the power negative n. Here n is 1/3, so here should be a negative 1/3. Okay, now we can find the fx. Fx equals x squared plus x plus 1. And what is the n? N is negative 1/3. Now we're gonna follow the general power rule. N is negative 1/3 times fx, x squared plus x plus 1 to the power negative 1/3 minus 1. Okay, and minus 1 times the derivative of fx. So we have x squared plus x plus 1 prime. Now here we have the derivative of the sum of 3 functions. That means we can do the derivative for each function. So we're going to copy the first 2 terms, and for the last term we're going to do the derivative for each function. And let's take a look each function. The first function, we can apply the power rule. It should be 2x to the power 2 minus 1. The second one, again, the special case. The derivative of x equals 1. And the last function, we can apply the constant rule. Should be 0. Now we can simplify it. We copy the first two terms. X negative 1/3 x squared plus x plus 1 to the power negative 4/3. And here should be 2x. And this guy will be 1. That's it.